Hello, judges. My name is Ann Licato. I am a 10th grader at Washington Liberty High School in Arlington, Virginia. And my project is the effective proximity of particles exhaled based on breath rate on the number of COVID-19 virus particles accumulated. In early March of 2020, the World Health Organization declared the COVID-19 virus a global pandemic. I'm sure that we can all agree that this pandemic has had a drastic impact on all of our lives over the course of the past year. So the CDC has advised avoiding public places unless necessary, staying at least 6 feet apart from those not in your household, and always wearing a mask to protect not only you, but those around you. Of course, I did my experiment before vaccines were readily available to all of us. So when a person who is infected with COVID-19 exhales, those virus particles spread all throughout the air and can then be inhaled by those surrounding the infected person. The purpose of my experiment was to determine how many COVID-19 virus particles are accumulated when standing at different proximities to somebody infected with COVID-19 and the position of the person infected with COVID-19 in the line, what would happen if that was changed. I chose to do my experiment because I'm extremely interested in virology. I have loved virology since I was in 7th grade, so a little over 3 years now. I wanted to learn more about viral transmission and viral spread and understanding more about viruses themselves. A few notes about the COVID-19 virus. The COVID-19 virus can only travel up to 4.9 feet and remain in the air for 15 minutes. We like to say to stay 6 feet apart. This is because it's a nice round number and we are really making sure that the virus cannot spread any farther. But when an infected person moves forward in, say, a line, they leave behind a cloud of virus particles that can then be inhaled by surrounding people. My hypothesis was if a person with a higher breathing rate was infected with COVID-19 and they stood in a line with a proximity of 1.5 feet to the people around them, then the people around them would accumulate more COVID-19 virus particles because the infected person had a higher breathing rate and they were standing closer to the people around them. For my materials and methods, I really didn't have that many materials. It was just me, my computer, my calculator, a few sheets of scratch paper, and a couple pencils. So I started by taking a random number generator to determine my breath rate using the average adult breath rate for 8 to 16 breaths per minute. I did this because I wanted a more accurate representation of the human population. And I also calculated the time taken to complete one full breath for each of the 10 simulated people that would be standing in my line. The total number of exhales in 300 seconds, which is equal to 5 minutes, was calculated. And then the total number of virus particles exhaled by each infected person was calculated. Each simulated person moved up one position, and then I calculated the number of virus particles left in the cloud. I repeated this process with each simulated person in positions 1 through 10 being infected with COVID, and then at different distances, 1.5 feet, 3 feet, and 6 feet. Each simulated person stayed in each position for 5 minutes before they moved up a position, or if they were first in line, then they exited the line if they were at the front. I chose to do a line that you could find anywhere, at grocery stores, post offices, banks, etc. So these were the formulas that I used. I was inspired with some of my formulas from a study that I read called a computer simulation study on novel coronavirus transmission among the people in a queue. Their formulas were a little off, and I did have to go in and check all of their formulas and change some of them around. So that was a little bit of a hiccup in my experimentation. So we have K equals 60 over BR, which is the time taken in seconds to take one full breath, equals 60 divided by the breath rate. Total exhale is the total number of exhales in 5 minutes. Time taken in seconds or minutes divided by K. And I calculated total number of particles that could potentially be inhaled times 100,000 particles per exhale. 100,000 is a standard constant. This is the maximum number of COVID-19 virus particles that can be exhaled by any person. It can't be 200,000, it can't be 150,000, it's 100,000. It can be 70,000, but the maximum is 100,000. So I did use the maximum in this instance. And then I calculated the total number of particles accumulated per person using breath rate. This is an example of my simulated model. I had 10 of these in my Excel spreadsheet. So I just picked one and put it on the slide for you to see. The red highlighted position is the position infected. So in this instance, we have position 4 infected. The yellow represents those that were exposed to the virus, and all numerical values are the total number of COVID-19 virus particles accumulated at different proximities. You can see along the top there we have 1.5, 3 feet, and 6 feet. So here's my data. On the left, we have my graph showing the percent of people infected based on what line position is infected, and on the right, we have the same, just in a table. Now, here are 2 more data tables for you. On the left, we have the table showing the total number of COVID-19 virus particles accumulated per each person being infected. And then on the right, we have a table showing the randomized breath rate per minute in that second column, and then the total number of virus particles exhaled when each simulated person was infected. So here are my results. I need to note 2 assumptions. 1, it was assumed that the simulated persons were not wearing facial coverings. They weren't wearing any masks to protect themselves from the virus. They also were not vaccinated. 2, it was assumed that 50% of the virus particles settled to the ground once they were exhaled by the infected person, which allowed 50% to remain in the air. Going back to what I said earlier about that study that I read and their math not being all that correct, I thought that I had found a great formula for settling velocity, quickly realized that it was not accurate. And when I tried to find a proper formula, another realization that happened was that I am a sophomore in high school and not a calculus major. So it was a little bit too far out of my league. So I just made an assumption. Now on to my results. Position 4 when infected caused the most spread of virus particles. So average 51.85%. This made sense to me. Position 4 is centrally located, has the highest number of positions in front and behind, so the most number of people got infected. However, the greatest accumulation of virus particles of all distances and positions was when position 9 was infected and at 6 feet apart. Position 10 accumulated 117,549 COVID-19 virus particles. That is a lot of virus particles. This at first was a little bit unexpected to me. I was like 6 feet apart, that's what the CDC tells us to do. However, when I thought about it, it makes sense because the person in position 10 accumulates all of those virus particles that are left in the cloud by position 9. So again, although the virus can't travel more than 4.9 feet, position 10 stands in every position behind position 9, and the virus can remain in the air for 15 minutes. I found that breath rate had little to no effect on the number of particles accumulated. Because the people in the simulated lines for 1.5 and 3 feet are closer together, and they are under that 4.9 feet mark, it makes sense that the virus particles do have more hosts to spread to, which results in more people being infected. But also, again, when I thought about it more, it did make sense that the most virus particles accumulated by one single person is at 6 feet apart. So because the virus remains in the air for 15 minutes, the simulated people who stepped into infected spaces for those following 15 minutes became infected with COVID-19. So in conclusion, my hypothesis was partially accepted. More people in total became infected when each person was standing 1.5 feet apart, even though the highest number of virus particles accumulated occurred when each person in the line was at 6 feet apart. Because of my findings, standing at the back of the line is not advised because accumulation occurs not only when you're standing in line, you think you are standing 6 feet apart and that you are safe, but when you pass through that cloud of virus particles, you can catch COVID. For future experiments, I could modify the time waiting in the line. I could include people wearing masks. I could try and calculate that particle settling velocity that I had such trouble with. I could also research into the necessary viral load to induce infection. So another thing, because of my findings, always wear your mask, go get vaccinated if you can, and try to keep you, your family, and those around you safe. Yeah, thank you.